Hello and welcome. I'm Shankar, your instructor for Statistics for Business 1.
And I'm Liza, his brainy assistant.
We've been talking about numerical variables. We learned how to summarize them in the context of a categorical variable.
I know we've aggregated tourism receipts by region.
We also learned how to visually summarize numerical variables using histograms.
That's how we compared 1995 receipts with 2010 receipts.
You got that? We have one last case to cover. A numerical variable in the context of another numerical variable. For this, let's continue with the same bivariate dataset that we drew up in our last segment. So let's get back to our growth tab. Each row that you see over here has two numerical values, one for the international tourism receipts for 1995 and the other one for 2010. Both of these are in millions of dollars, remember. We can ask, is there a clear relationship between these receipts? If you were to go down, you see that the US made something like $94 billion in 1995, whereas it was $165 billion in 2010. China made $8.7 billion in 1995, but look what happened. In 2010, it rose all the way up to $50 billion. That's a meteoric rise.
I can see a strong relationship between them. Yep.
Now, this is a quantitative course, so we must be more precise. Suppose we had a bivariate data set for two variables, x1 and x2. How would we visualize their relationship?
That's easy. Just plot the two variables.
Right. And that's what we call a scatter plot. Now let's suppose we had to compare two such data sets and say something about the relationship between x1 and x2.
I think that the first plot shows a stronger relationship.
Now how would you summarize the strength of that relationship?
You mean with a number?
Absolutely, Liza. Now you're thinking like a quant. And this number is what is popularly called correlation. I have the bins over here, and I'm going to click on column, clustered column chart. So here I'll go ahead and select the data once again. And this is my clustered column chart. One general trend that we can observe is that the bars have moved to the right.
That's more countries with more receipts.
That's right. But this doesn't tell us anything about what is happening with a specific country. So we'll use a scatter plot. Let me go ahead and grab these 2 years worth of data and insert a chart for a scatter plot. Now notice the point on the extreme right at the top. It appears to have created a lot of white space.
Yes, how about we get rid of it?
That's a good observation, Liza. The point, of course, represents the giant in our data set, which is the United States. There's no reason to fully eliminate the US from this study. Now you might think that if we cut out these 5 points on the right, we'll get an even better picture.
These are outliers.
Remember, this is a quant course, so we must devise a way to systematically identify outliers. We will discuss that next week. Now there are two approaches. We could use a measure we talked about earlier, that's correlation. Another more advanced concept involves a regression fit. We will skip that for this session. Correlation is a measure prescribed on any bivariate dataset such as ours. This measure has no units and varies between -1 and 1.
I'm assuming you'll tell us why later on?
Yes, don't worry, Lisa. When we talk about random variables, we'll go over this in far greater detail. For now, I'd like you to get an overall idea of the measure, that's all. Correlation depends on the direction of the growth. If the incline is generally positive, then so is the correlation. Otherwise, we get negatively correlated variables. Inverse relationships give us negative correlations, like the weight of a car versus the mileage it can give. The more the weight of the car, the less the mileage. You get the point? So I have correlation given by correl x values, which is in column B, and y values, which is in column C. Now, how do we interpret this correlation? With one single number, correlation tells us how predictable the value of one of the variables is if we are supplied the value of the other variable. For example, if all of our points were to lie on one straight line, life would be simple. Given x1, we could predict the exact value for x2 by just figuring out the line's equation. In fact, correlation tells us how close our data set is to a line. But all data sets are not this simple. The reality with our data set is that two countries could probably have the same receipts for 1995 but end up with different receipts for 2010. Here's a case in point. Slovak Republic and Barbados both start off at $630 million in 1995, but just see what happens. So how predictable is that? Now the spread of the y values for the same x value leads to diluting the correlation from its perfect value of 1. The more the variation in these outcomes, the higher the dispersion in the plot, and the closer towards 0 the correlation becomes. How about we let you figure out all this with a picture? The formula for correlation is quite involved. We will see what it is when we take up the topic of random variables. Now, before I close, let me go over one common mistake that people often make. Just because the correlation for a data set is 0, we must not conclude that the variables are unrelated. We've created a special exercise for you where you'll arrive at this conclusion on your own. And with that, we'll come to the end of session 2 of our series.
Maybe you can correlate the time you've spent watching our videos with your performance on our questions.
And I hope you're happy. See you next week.